So you're an engineering student or thinking of becoming one. You may be wondering, what do engineers do exactly? What is different between one engineering discipline and another? And why are there so many disciplines in the first place? Well, consider your average vending machine. It stores products and delivers them on demand. Simple, right? But do you realize how many different types of engineers it takes to manufacture one? To produce just this one machine, it requires the skills of mechanical, electrical, industrial, and computer science engineers. Look at the mechanical engineer's role. They design the system to keep food fresh and drinks cold, but equally important, they ensure safe product delivery. When a product is selected, a screw-shaped wire turns a coil, forcing the item off its shelf and into the delivery chute. Too much pressure and the product is damaged. Too little pressure and the product remains stuck. Electrical engineers perform their own balancing act between power consumption, heat output, and Energy Star standards. To do this, they design microcontrollers that run and monitor various systems within the machine. When a selection is made, a microcontroller sends electrical signals to various motors that enable payment and deliver the product. These microcontrollers also regulate the cooling systems to keep food fresh and drinks cold. Too little power can mean jammed sodas or melted ice cream. Too much power can cause excessive electrical heat or burned out circuitry. Industrial engineers focus on human factors and design the equipment to work with the human body in mind. What if it isn't obvious where to make payment? Is it intuitive how to make a selection? What if a child is making the purchase, or someone in a wheelchair? Will they be able to reach the selection or payment interface? Can they remove the product itself once delivered? An oversight here could mean frustrated customers and lost sales. Last but not least, computer science engineers create the content that is displayed on the customer interface. They not only need to create software that is easy to navigate when making a selection, but also a secure method of money transfer for debit and credit card transactions. And they have even bigger challenges with today's modern wireless communications. Vending companies want to know the machine's status at any time, and connectivity allows them to change prices, check supply levels, and capture sales trends online without ever going to the machine itself, all thanks to the work of computer scientists. As you can see, a lot of expertise goes into making a simple vending machine. Imagine the collection of skills and teamwork needed to design and manufacture a handheld smart device, an automobile, or the Mars rover. Each engineer plays a vital role in bringing a product from concept to reality. For more details on what engineers do, check out the link What is Engineering at staywithit.org.
Wow, what is engineering? That's not an easy question.
Engineering's a lot of fun. That's what it is to me.
Engineering's all about discovery.
Looking at the real world and figuring out something new.
Engineering's all about creativity.
Making some stuff that is really cool, that's really awesome.
And engineering's all about solving problems.
Turning what you design and imagine into reality.
To be a good engineer, I think you need to be able to think critically, to see more than just what's right on the surface.
You don't need to be very smart, but you should have the passion. Otherwise, you won't have the determination to go through whatever technical issue or problems you have to solve.
A really good engineer always asks questions. They see something and they wonder, well, how does that work behind it?
Someone who is willing to be really dedicated to what they do.
To kind of focus and analyze things as like a system, and see how things flow and move together.
Pretty much building anything on a fundamental level.
Engineers do a lot of cool things.
We design almost everything that everybody ever consumes ever.
Little robotic technology that you can use in medical uses, whether that's a prosthetic arm that can move when you think.
You look at a computer and you wonder, well, how does that work? And there's a lot of things that go behind that. But you look at a car and you ask, how does that work? You look at a building and ask, how is that staying up?
We just design, build, and test really cool things like solar cars.
If you like your project, it can really kill your time and you can have fun with it.
basically the world wouldn't function without engineers because we make almost everything.
So in a way so that we can make our world better, you know, change it in a way that we have control over.
Over there in front of the clock tower, perfect.
Didn't have a chance to get a haircut or anything.
You've probably heard the word engineering before, and you've probably been told it's pretty important. But what exactly is engineering, and who exactly is an engineer? Engineers are people who design and build things that we use every day. However, they don't just go building the first thing that comes to mind. They work hard to make something we need, and they want to do a good job of it. So how do engineers decide what they need to build? Well, in most cases, they start with a question. Here's an example. Say you live on a space station and something outside breaks. Obviously, you need to go outside and fix it, but how exactly do you do that? That's a great question for engineers. Once they've got a good handle on things, they'll start imagining ways to solve the problem. They'll come up with all kinds of ideas, and some that might even seem a little crazy. That's important because sometimes the craziest idea is the one that works best. After coming up with these ideas, they'll pick a few that make the most sense. Next, they'll start drawing a plan. Depending on the idea, the plan can be very simple or very complicated. But the important part is the plan itself. A good plan helps engineers focus on what they're making and, most importantly, why. Now the engineers get to have some real fun. They get to create something. It's important to stick to the plan, though, so the idea doesn't go too far off course. Once they've built it, then they have to test it. Experimentation is very important because it's here that engineers learn what works and, well, what doesn't. And while it's great when something goes right on the first try, it's actually good when things don't, because that gives engineers a chance to go back and improve on their original idea. And improve they will until they've solved the problem. So the next time you've got a problem to solve, whether simple or complicated, there's probably a team of engineers ready to create something to solve it. And nobody solves engineering problems quite like NASA.
When I look 5 to 10 years out and think about what are the exciting areas when it comes to engineering, I'm always astounded by what we're going to be able to do. If you want to work in biology, if you want to work in aeronautics, if you want to work in space, every aspect of all of these industries in the future are going to need engineers.
We have gone through a period of ignorance as to the impact of humanity on nature and the impact of nature on humanity. And as we get to a period of technological enlightenment, it's exciting to think about the roles that engineers will be playing in solving problems that we're going to have, like dealing with trash through innovative recycling methods, making products that are much more optimal in their use of resources.
I think the world is getting smaller. More people have passports now, people travel. You kind of see people of different sizes, different shapes, different abilities. The world is really, really changing. You try to figure out who are these people, what culture they live in, what lifestyle they live in, and how can you make their life better.
One of the things that I'm most excited about is as we approach the year 2020, the size of meaningful computational power, so the size of the chip that we put in devices, approaches zero. So what that means is we can put a chip into anything. We can make everything smart. We can make this chair smart. We could make my jacket into a computer. We will be surrounded by computational intelligence.
As consumer electronics become more a part of being us, the standard that these things have to be designed for has to be much, much higher. And I think that's a really interesting place where you're going to see a lot of innovation. Is it how I want to express myself? Is it something that I actually want to live with? And that's where I think the voice of women coming in is going to be really important to be heard.
If you want to change people's lives, biomedical engineering is the best place to do that because we can create the engineered devices that adjust the functionality of somebody's body in a way that addresses some malfunction of natural processes, and that means that you will be directly affecting the life of an individual.
You're going to have the capability and have the tools to work in areas like architecture. And the tools that we're creating for that completely change how we conceptualize the world and conceptualize buildings and conceptualize bridges. And then one of the things that you could work in, that why you wouldn't work in this, I have no idea, is robotics. There's going to be these incredible advances in robotics, not only industrial robots, but medical robots and personal robots.
Engineers don't need to have the large infrastructure around them to be able to make big change in the world. They need a good team of friends, they need a little bit of money, and they need great ideas. Now we're at a point where you can go from something in your imagination to something that's in the marketplace in a short time span without having to spend a lot of money. I can look up online in a catalog and find all the parts I need in an hour. I can 3D print things that I don't have. That, I think, is incredibly transformational.
There is this link between entrepreneurship and engineering, which I think is definitely getting stronger. If you have a great idea, you've got skills, you can build something, you can go out there and just start your own company.
What gets me excited about tomorrow and 10 years from now is I see the impact of engineers being very direct, creating better conditions for living, to create better harmony between humans and the nature that sustains our lives.
And that's where the opportunity is for this new crop of engineers. How can I make the world better for everyone else? How do we take that status quo and make it reflect what the world is becoming today?
There are so many jobs today that we didn't have 10 years ago. And there's going to be even more jobs 10 years from now that nobody could even dream of. And that's what this engineering education will give you, is that ability to follow your passions. I think the future is going to be awesome because we're going to build it.
Hi, I'm Savannah McCoy, and I'm the rover verification and validation lead. My job is to run system-level tests on the rover structure to ensure it's capable of the requirements we have for Mars. Basically, for the Mars program, we build 2 rovers in parallel. One's the flight rover, and one's the test rover, or DTM. The main difference between the flight rover and the DTM rover is that the flight rover actually goes to Mars. Just recently, we ran a major test called the SkyCrane Full Motion Drop Test. This test is to check out the EDL sequence, or entry, descent, and landing sequence, for Curiosity. For the first time, we're going to be touching down on Mars with just the rover's wheels. So this is the sequence leading up to that touchdown on Mars. Because this test is so important to the project, almost all of the team wanted to gather and watch the test. We actually projected it into multiple conference rooms around the lab so that everyone could have access to this very large milestone for our project.
Test is commencing in 5, 4, 3, 2, 1, fire.
The reason we do all this testing is to prove that what we think is going to happen actually will happen when Curiosity gets to Mars, and that we really understand the dynamics of these vehicles. During this test, everything behaved as expected. We were able to collect all of the data and instrumentation that we were hoping for, so overall, definitely a huge success. I'm Savannah McCoy, and this has been your Building Curiosity Update.
Now, what would we do with this one? How would we mark this thing? What do we do?
I think engineering technology is what engineering was maybe 20 to 30 years ago. It's a real emphasis on applications.
It's applying problem solving along with those technologies. So it's not just pushing a button and getting the answer. It's actually using applied reasoning.
It's for those types of people who are often asking, how come? What if? Could I make this better, faster, easier? For the inquisitive mind is really what engineering technology is all about.
Engineering technology, we actually get to design and build it and see how it does if we have to make modifications. So it's a more hands-on engineering than just straight up engineering.
You're going to wire up this cable. It's going to be an analog channel, so I'll go through that in a second. I would say the key word is applying. We're more focused on getting stuff out in the field, hands-on experience. We're much more lab-driven, really putting the tools on something along with the classroom, learning it.
In my own case, I may do some design work on a machine and actually build the parts that I design.
Definitely hands-on, maybe not so much as actually swinging the hammer for a construction company, but working for the construction company instead of the designers.
Yeah, it was because he was using the neutral. So you can take that up to about 120.
We live in a society where it's very difficult to repair things in the field, so we actually get engineers ready to do applications to solve real-world problems. How do we get things to work, and how do we fix existing issues from an engineering perspective?
You do a lot more hands-on things all the way through your 4 years. It's not just labs here and there, it's big projects all the way through.
It's nice to see how everything fits together, how you can design it in a computer, and then see how it will work and what will work and what doesn't, seeing if you need to make different tolerances, bigger, smaller.
By the time we leave here, companies know that we've had these labs. We haven't just seen this on paper, but we've actually put a screwdriver on something, hooked the wires up, and seen what you've designed run in a lab environment.
It might have looked good in the book, it might have looked good on paper, but in reality, we've got to tweak this a little bit. So it's really for the problem solver.
The best surgery is the least invasive. Doctors are reducing scars and recovery times by using instruments conceived and designed by engineers like Adam Ross, who have placed amazing new tools in the hands of surgeons.
I'm a design engineer and I work as part of a team. We manufacture all sorts of different surgical instruments, surgical tools, staplers, graspers, shears, all different kinds of instruments you'd find in a surgical suite. I'm working on prototypes, instruments for the future. So what I do is I'll go out to surgeons, we'll get feedback, listen to them, talk to them, see what they would need, what they would like to have in the OR suite that they don't currently have now.
So where are we along here with the progress? Yeah, the progress is going to be working right in this area.
We'll come back and we'll start to do designs. Basically, we'll sit down at our computers, draw stuff up in CAD, sketch notebooks, we'll have brainstorming sessions. Once we do a design, we'll have it, we manufacture it here, we do the prototyping here, we'll take them out to surgeons again and get their feedback. Basically see what they like, what they don't like about it, and come back and we'll do it again until we get it perfect. It's definitely not the same thing every day. We're always doing something different.
Allow us to hit the detail really close.
As a kid, I always loved tearing things apart. I always loved understanding how things worked, why they worked. And from an early age, I remember my mom telling me I used to take like a lamp apart and figure it out and take it all, have all the parts disassembled and be, look what I made, look what I figured out how this kind of works. The other thing is figuring out how to put it back together, and that was always the more complicated part.
The safety latch is there to prevent the surgeon from pre-firing the instrument.
or the thought of becoming an engineer was kind of something I grew up with. It always seemed to be part of what I did and part of what I enjoyed doing. I enjoyed my math classes, I enjoyed my science classes, I enjoyed physics quite a bit, and I enjoyed the lab portions of what I did. I enjoyed the hands-on. After I got out of school, I did start an internship here at Covidien, and through working and being able to show off what I could do, my skills, my different attributes, it was able to turn into a full-time position. I think one of the big things is people skills. You got to have good communication, so you have to be able to interact, understand, and be able to communicate effectively. Got to be good at math. There's plenty of math that's involved. Definitely have to be good at computers. That's what we do. A lot of what I do is based on the computer designs. I just enjoy the challenge of what I do. I enjoy the challenge of making this instrument work, and I enjoy in the end being able to take it out and see it function. That's what gets me going in the day, when you can take the instrument you worked on and you actually go and use it and see it being used and have it function properly. And you know, when the surgeon says he loves it, he gets excited, that's right there. That's when you know you've done a good job.
Hi, my name is Dave Gruhl, and I lead the team responsible for assembling, testing, and launching the next rover to land on the surface of Mars, Curiosity. The team just recently installed the mobility system onto the sides of the rover. That's the wheels. There's 6 wheels, 3 on each side, that all have to be verified that their actuators work. And then there's steering actuators too, which are what we use to actually turn the rover when it's on the surface. There are 10 small little motors that make up that mobility system, and what the team is doing right now is they're going through and making sure that each of those wheels spins forward and backwards and rotates if necessary from a steering point of view, so that when the rover gets down to the surface of Mars, it can successfully navigate itself over the rocks and the terrain that are actually there on the surface. As soon as we finish up the mobility checkout, they'll be putting the mast on the top deck of the rover, and the mast is more cameras and imaging that allows us to take stereo pictures off in the distance of Mars. Just like your eyes work in a stereo pair, this camera will also return us stereo imagery from the surface of Mars. Once that's complete, then the front deck of the rover, which is empty right now, is where we'll put the robotic arm. The robotic arm is a device that reaches out 6 feet or so and actually touches the surface, takes samples, and then deposits those samples back into the innards of the rover for the science instruments to analyze and determine what the elemental compositions are of the surface of Mars. Over here on my left, you'll see the descent stage. The descent stage just went through a test where they actually shook it, just like it would experience when it's out going through the launch. And they wanted to make sure that the design held together and that nothing broke, and everything was successful with that test too. This has been your update on the assembly of the Curiosity vehicle. As you can see, Curiosity is looking more and more like a rover every day, and the team is working hard as we aim for our launch scheduled for November of 2011.